Ignition sequence start.
Good morning. Welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room and the Orbit 2 shift of flight controllers, the specialists who are monitoring the systems on the space station and working with the Expedition 58 crew members as they move through the last few hours of their scheduled work week. Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques have had another week filled with a wide variety of work. They've, of course, been taking care of their home on orbit, also checking out their spacesuits in advance of upcoming spacewalks, and preparing a science experiment to go out the airlock.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, astronauts inside the space station prepared an external experiment that will test the ability to store fuel for future missions. NASA astronaut Anne McLean and Canadian Space Agency astronaut David St. Jacques prepared the Robotic Refueling Mission 3, or RRM-3, for its transfer outside through the airlock in the Japanese experiment module. RRM-3 demonstrates the first transfer and long-term storage of liquid methane, a cryogenic fluid, in microgravity. Spacecraft use cryogenic fluids as propellants or coolants, and being able to refuel while in space will be a huge boost to enabling long-duration missions to future destinations like the Moon or Mars. A suit can make anyone look their best, but it's critical for astronauts that their spacesuits work their best. Spacesuits require routine maintenance to ensure they are in proper condition before an astronaut ventures outside on a spacewalk. Spacesuits are like individual human-sized spacecraft, each containing its own portable life support system. This includes the fan pump separator, which circulates air through the oxygen ventilation circuit and transports the suit's coolant fluid. Astronauts Anne McLean and David St. Jacques removed one suit's fan pump separator and replaced it with an on-orbit spare, then pressurized the suit to conduct a leak check. This week's question comes from 5th grader Oliver, who wants to know if there's internet in space. In fact, the World Wide Web extends beyond the world and into space as well. Astronauts have access to what we call CrewNet, internet available on tablets aboard the International Space Station. Crew members are able to send emails, and many even have social media accounts. You can follow NASA astronaut Anne McLean on Twitter at AstroAnimal and Canadian Space Agency astronaut David St. Jacques at Astro_DavidS. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
This morning, McLean and St. Jacques are reviewing procedures for something that has never happened at the International Space Station before: the arrival of a crew vehicle provided by a private company. SpaceX's Crew Dragon spacecraft remains on target to launch on its uncrewed first-ever test flight next Saturday, March 2nd. It's another step in NASA's Commercial Crew Program's effort to move America closer to the goal of restoring the capability to launch astronauts to space from the USA.
Stand by for terminal count.
Stage 2, pressing for flight.
5, 4.
The purpose of the Commercial Crew Program is to return to our nation the capability to fly our astronauts to the International Space Station.
Ground gas closeout are complete.
3, 2, 1.
This Commercial Crew Program is the beginning, I think, of an entirely new era.
Go for launch. Side booster ignition.
Liftoff. Astronauts taking flight once more from American soil as the nation begins a new chapter of space exploration.
Stage 1 propulsion is nominal.
This is us as a nation. This is us as a NASA private-public partnership together, allowing our nation to capitalize on what they've invested in within NASA to be able to create this industry.
Both of our companies, Boeing and SpaceX, are incredibly capable companies.
It's just an awesome feeling to see the hardware coming together and seeing, the excitement of the technicians, of the engineers.
It's going to be wonderful to see the crowds come back. And this is great to get the public kind of re-engaged on human spaceflight again.
The Commercial Crew Program is revolutionary in a sense where it's going to provide us the opportunity to have more astronauts in space. It's going to further our ability for knowledge in a microgravity environment.
We need to explore, we need to pioneer, we need to see what's out there and find new places to live.
The International Space Station still has a lot to teach us.
I think we're going to have a lot more opportunity to do the exploration research that we need to get us to the moon and to Mars and beyond.
There's a larger group of us that are dreaming that potentially could have a ride someday and be working in space.
It's a huge goal, a huge accomplishment for both for partners, NASA and the United States of America.
The fact that we're able to partner with commercial industries allows us to fulfill that mission, to be explorers, because we can work together.
This is just the beginning.
I know the greatest events in space exploration have not happened yet, and that our destiny lies above us.
NASA TV and NASA.gov will have plenty of coverage of activities surrounding the Crew Dragon's first flight. It'll actually start later today, February 22nd, with a briefing following completion of the flight readiness review. That'll be no earlier than 5 o'clock Central Time today. There'll also be a pre-launch briefing next Thursday, February 28th. Time on that still to be determined. And launch coverage begins on Saturday, March 2nd at 1 a.m. Houston time. And that'll take us right up through the targeted launch of the uncrewed Demo 1 flight at 1:48 a.m. Central. We'll have live coverage of rendezvous and docking of the Crew Dragon to the International Space Station next Sunday, March 3rd. That'll start at 2:30 a.m. Central, and then be back at 11:15 p.m. Central next Thursday, March 7th, for hatch closure, followed on into Friday morning, March 8th, with undocking and then splashdown. So lots of fun. And NASA's effort to promote the commercialization of spaceflight takes another step with this first flight test of a commercial crew vehicle. It's already succeeded in helping get 2 commercial cargo vehicles making supply runs to the International Space Station. Another example of the results of that effort is Alpha Space, the company responsible for developing the Missy flight facility.
Alpha Space was formed in 2015 and really is a product of this new commercialization in low Earth orbit. It was formed specifically to create a commercial payload that would be available in space for private industry. The Missy dates to the early 2000s, was the first mission. It's been utilized by NASA, by the Department of Defense for different experiments. And then around 2010, NASA put out a call for ideas to privatize portions of the space station. And so we responded with a proposal to that, and that's how we ended up with our cooperative agreement. For material scientists who want to test their materials or components in a harsh environment, the Missy platform really offers the most harsh environment that's available, and that's external to the space station. Previous Missies were one-time use, sort of suitcase style. They would open up and expose these materials to space. The Missy platform is a permanent platform that's all robotically serviceable, commandable from the ground from our operations center here. We don't only test materials, we can also do technical demos, we can test circuitry, computer boards, cameras, and its serviceability and changeability allows science to continuously happen for 10 years going forward. Every day, new commercial companies are coming into the fold of this new economy that's developing. I think the space station is a great platform to start commercialization, and I think platforms like the Missy are going to drive a new demand in space.
Flight engineer Ann McLean will be one of the crew members involved with the rendezvous and docking and the packing and unpacking of the Crew Dragon. It's part of what she trained for during more than 2 years of preparation for her first spaceflight. McLean says that her training benefited from something that she learned about achieving goals. It was something that she learned from playing rugby.
So the first time I played rugby, I was actually 18. It was the year before I went to West Point, and I was walking across the Gonzaga University campus, and I saw a group of people playing a sport that was unlike anything I'd seen. There was a lot of tackling. I couldn't figure out what was going on. And one of them asked me if I was interested in trying it out, and the very next day I started in my first game of rugby. I played throughout my time at West Point, and then when I was a Marshall Scholar, I was fortunate to study postgraduate in England, and there I started playing at a higher level. In 2004, I was selected to the U.S. national team. I was fortunate to play a lot of rugby, and then I also coached a little bit right before I went to test pilot school. My last weekend playing rugby was the weekend prior to finding out I became an astronaut. So rugby has surprisingly helped me a lot as an astronaut, and when I'm training in the spacesuit in the EMU and we're working in our large pool, the neutral buoyancy lab, underwater, we're under there for 6 hours at a time, and you really work yourself to physical and mental exhaustion. The only other time that I've hit that point of exhaustion is the 60th minute of a rugby match. When your body gets that physically tired, you can't mentally give up. You actually have to think about things more deliberately, with more clarity, because you're more prone to mistakes. And it's the people that can overcome that physical and keep going with the clarity of mind that win both rugby matches and that find themselves successful training in the spacesuit. I am Anne McLean, and I am an astronaut.
Along with hands-on work with science experiments and visiting vehicles, International Space Station crew members use some of their time for educational events in which they talk about science with students on Earth. They discuss their mission, share the value of learning about science, technology, engineering, and math. Explaining STEM topics to students is an important part of the station's overall education mission. In this demonstration video, Randy Bresnik demonstrates Newton's second law of motion.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Surely good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small, something you might have at home. A little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. And let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration's faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
The International Space Station's mission is to serve as a science laboratory to support future exploration into deep space, promote international cooperation, and encourage the commercialization of space flight and space research. Now, all of these goals come together in just one program, when the International Space Station is used as a launch pad for a series of small satellites known as CubeSats.
Small satellites yield big discoveries. Presented by Science at NASA. Remember the old adage, big things come in small packages? NASA has updated it in the form of CubeSats. Imagine a real working satellite that's so small you can hold it in your hands. Just 4 inches or 10 centimeters across, these cubes can be expanded incrementally depending on their specific mission objectives. Originally developed in 1999 by Cal Poly San Luis Obispo and Stanford University for education purposes, NASA has since used them for new science missions and to test new electronics, sensors, and software that might be included on larger missions. Mike Sieblum, Chief Technologist for NASA's Science Mission Directorate, says, "The ability to test new technology at a fraction of the cost of a larger satellite makes them invaluable. It really opens your eyes to many possibilities." Just as eye-opening is the way CubeSats are quickly unlocking new scientific data. For example, while conventional satellites have long observed clouds and have provided estimates of the liquid precipitation they hold, they have never observed the smaller ice particles that create enormous rain clouds. The CubeSat, known as IceCube, contained a new sub-millimeter wavelength radiometer that could make a space-based measurement of the small frozen crystals that make up ice clouds. After being deployed from the International Space Station in May 2017, IceCube created a global map of ice clouds around the planet. Someday, this technique may help improve long-range weather models and forecasts.
A long way from Earth, Marco A and B travel to Mars and are the only CubeSat so far to leave Earth's orbit.
When the InSight mission was launched in May of 2018, the Marco A and Marco B CubeSats also began their 7-month journey to Mars.
Now InSight has successfully landed on the Red Planet. One of Marco's roles was to help relay communications during InSight's landing process. Landing data was transmitted to the Mars Reconnaissance Orbiter, where its radio stored and forwarded results to Earth after a delay. Marco A and B acted as a bent pipe signal relay during this critical stage of the mission to allow communication from Mars to Earth to happen in almost real time.
According to Charles Norton, Special Advisor for Small Spacecraft Missions in NASA's Science Mission Directorate, another advantage of these compact cubes is they allow for very focused scientific inquiries to take place. The Miniature X-ray Solar Spectrometer CubeSat, or MINX for example, is a student project using a commercial laboratory detector in space. MINX measures the soft X-ray solar spectrum in the gap of energy coverage between 2 other missions, RESI and IRIS. This gap region in the solar spectrum is important in the excitation of the Earth's ionosphere and of particular interest for observations of solar flares and active regions. Or consider a discovery as monumental as the origin of the universe itself. One long-standing mystery for astrophysicists is where 1/3 of the baryonic or ordinary matter that existed during the early formation of the universe might be found today. Scientists suspect it lies in the very hot halos of gas that surround galaxies. HaloSat is a CubeSat that will examine X-rays from oxygen atoms surrounding our Milky Way to determine how much missing matter may lie in the halo of our galaxy. While small in size, CubeSats have potential to make big scientific and technological impacts on Earth, in our solar system, and deep into the universe. For more about other science missions, both big and small, visit science.nasa.gov.
The Johnson Space Center is not just the home of human spaceflight in America. Extraterrestrial materials have called JSC home since Apollo missions returned samples from the moon, and we're still adding to the collection. When JSC planetary scientist Dave Middlefelt of the Astromaterials Research and Exploration Science Division left on his 5th trip to Antarctica, looking for meteorites that can teach us about the formation of the solar system and the evolution of the Moon and Mars. We went to see what does one pack in the way of personal items for a trip to the bottom of the world.
Hi, my name's Dave Middlefelt. Everyone knows me as Duck, so you can feel free to refer to me by that name. I'm a planetary scientist working with NASA Johnson Space Center. I've been doing planetary research basically almost all my career since the mid-70s on, and I'm about to get ready to go to Antarctica, so I've got to make sure I've got all the items I need. We're down there to collect meteorites that have been falling on Antarctica all over the place. These rocks are basically a poor man's space probe. For fairly low expense, we can sample a multitude of bodies in the solar system, and by studying them in the lab, we can then learn quite a bit about the formation of the solar system, and for the Moon and Mars, how those bodies evolved over geologic time. Christchurch is just in late spring, going on to summer, so I've got to make sure I've got shorts, t-shirts, and sandals available, because I don't want to be wearing sweatshirts, flannel shirts, and that sort of thing in 90 degrees in New Zealand. When you're in Christchurch, New Zealand, you get almost all of the ECW, or extreme cold weather gear, you need from the Antarctic terminal in Christchurch, New Zealand. So I don't need to worry about heavy boots for out in the field. I don't need to worry about fleece layers. I don't need to worry about parkas. But what I do need to take is some personal gear, woolen socks. These will keep my feet warm in my boots. They look kind of small, but they work. I only have one pair with me, and the reason is because I shipped my own personal ECW gear out from Houston, so it's already in McMurdo waiting for me. I do have to have one set because they will not let you on the plane from Christchurch to McMurdo Station if you don't have the proper ECW gear with you. One pair of expedition weight thermal underwear, and I've got, I think I took shipped 4 other pair down there, so I'm all set. McMurdo Station is, it's going to be cold down there. It is the summer. Temperatures will be below freezing almost the entire time. But it's not like you're out in the middle of nowhere. You're kind of in any town in Minnesota in the winter. So you want to have stuff to keep warm outside. So I might include a fleece pullover. That's always good to have. You need flannel shirts. The other thing is you need a good pair of hiking boots. These are mine. The dust there is from Death Valley. I was there last March. Now, sleeping in the tent in Antarctica, you're sleeping in a sleeping bag. The only time I really change down there is at night. I shed my daytime clothes and wear what I'm going to sleep in. What I like is a sweatshirt and basically some kind of running pants type things that are warm. The sun's up 24/7. So what I do is I take a heavy knit hat. You need to keep your head warm when you're sleeping, and then I just pull it over my eyes and it's dark and I can go to sleep, no problems. I can't do without coffee, but I'm not going to drink instant coffee. So this is a coffee cone. I will ship this. Actually, I'll take this with me. And cone filters. I've also already shipped cans of coffee already ground that I like, so I can enjoy all the comforts of home minus the heat while I'm in Antarctica. One of the things you probably never thought about for Antarctica is sunburn. Like I said, the sun's up 24/7. The scene around you is extremely bright. It's all ice, light blue ice or white snow. Sunlight reflects off of all of that, and even though the sun is at a low angle to the horizon, you can get a wicked sunburn on anything that's exposed. The other thing you need, these are my Glacier glasses. I bought these, the frames, and had my prescription put in them. They come with side shields. They're very dark, so when I put them on, basically the light is blocked all the way around. That way I won't get snow blindness. One of the times I was down there, this would have been in 2001 trip, we spent 4 days solid stuck in our tents with basically hurricane force winds blowing. So we didn't go out unless we had to, and we certainly didn't go out and work. So you need something to read. The advantage of this is that this right here, which weighs almost nothing, is equivalent to, a whole suitcase full of books. Sometimes power is at a short supply. We take solar panels so that I can recharge my Kindle, but sometimes you need paper copies, so I like taking cryptogram books. They occupy my mind. I lived in Israel for 6 years. I'm taking a novel in Hebrew and an English-Hebrew dictionary. This time, if we have tent days, I'm going to try and refresh my memory on how to read Hebrew. Everything is frozen, no surprise there. The good news is you don't have to refrigerate anything. You just leave it in a box outside your tent, and it'll stay nicely frozen the whole time. You never have to worry about it. There's tons of water all around you. If you want to make a cup of coffee, the first thing you do is you go outside your tent, chip a block of ice, put it in a pot, turn on the gas stove, and wait until the ice melts and then boils, and then you can make yourself a cup of coffee. But there's no shortage of water out there, that's for sure. Come about 4 or 5 months from now, we'll hopefully bring back maybe 1,000 new meteorites here, store them over there in Building 31 North, and then have them go through processing and distribution to scientists for study. This is going to be an exciting time. I'm looking forward to it.
If you'd like to get another look at any of the stories we featured today, you can. Check us out on YouTube and Facebook. There are the addresses for both sites. And while you're at either one of them, make sure to look around, because there's a lot of other very interesting things you can find out there about NASA and America's human spaceflight program. While you're out there on the internet, you can also check out Houston, We Have a Podcast. That's folks here at NASA talking about their work in all aspects of space exploration. We post new episodes on Fridays, and today, just 1 week before the first test flight of a commercial crew spaceship, we get a lesson on all things commercial crew in a talk with Program Deputy Manager Steve Stitch. Go to nasa.gov/podcasts. You can find today's episode there and all the previous episodes as well. Fact is, you will also find the full library of all NASA podcasts there. And you can listen to any of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.